Good afternoon, Kentucky Science Center. Are you ready for the explosion of the day? That's pretty good, that's pretty good. I won't even ask you a second time. All right, well, thank you for coming out on your 4th of July to spend it with me and do an experiment with me. My name is Zach. I'm a scientist here at the Kentucky Science Center, and this explosion has to do with an experiment that is all about pressure. So, we're going to see how pressure reacts in different ways to temperature and maybe even volume, okay? So, do we know anything about pressure? Can anybody here, adults, maybe you can help me out, what do we think of when we think of pressure? Pressure, 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 yes. Pushing, yeah, you can push on my hands right now, right? And we exert pressure on each other, right? Yeah, that's a pretty good explanation. Can anybody else give me a little bit better explanation, maybe? I don't think so. That's pretty good. It's a force, okay? And we can use pressure to move some stuff. So the first experiment we're doing here has to do with Alka-Seltzer, water, and a little piece of history we call a film canister. Okay? So right here in my hand I have a film canister. Do you know what the film canister is? What's a film canister?
It's a little cube.
It's a little thing like that, right?
And I also already know this trick.
Oh, you already know this trick? Alright, well.
This is where the water, and then you close the top, and then wait for a while, and then it pops out.
That's exactly right. That's an exact explanation of what's going to happen here. So we're going to use this film canister because it's plastic and it creates a seal with its lid. And it's not too strong of a seal. We can break the seal with a little bit of pressure, okay? And we also have Alka-Seltzer. Effervescent plugs, right? Plop, fizz, fizz, oh what a relief it is, right? And this is going to release gas, okay? Sodium carbonate, CO2. We're going to release gas with this, and we're going to drop it in this water, and as we drop it in the water, that medicine's going to start to dissolve, releasing the gas, okay? And we're going to trade the water for gas. Does that make sense? And that's going to create a lot of pressure. It's going to build up, and then it's going to pop off. So, first things first, let's go ahead and do this, right? I got a couple different canisters. We're going to go 8 for 3 today, and you guys up there on the second floor right here, like you 6 people right there, you guys are going to catch these if they come up there, okay? That'd be incredible. We're going 3 for 3, all right? Here we go. So the first round of Alka-Seltzer, first round of medicine, going into the first canister. Here we go. Everybody ready? Give me a countdown from 3, 2, 1. Canister goes on. Turn it upside down and count down 10. 9, 8, 7, 6, 5. Oh, there we went. That's 1. We got 1 for 1 so far. That's doing so far so good. All right, how about the next one? What do we think? Just a little bit less water this time. Going 3 for 3. You guys be ready, because I think this is a keeper. Okay. Here we go. Give me a countdown from 3, 2, 1. Cap goes on top, make sure it's good. Turn it upside down and we can help it out. 5. Oh, there we go. Look alive. Very well done. Alright, so you can tell that we have a lot of pressure building up inside this film canister, right? And it's too much for that lid to put onto, and it has to release. Alright, so I got one more here, one more. We're going for the trifecta. Do you think we can do it? All right, I think our odds are in our favor here. Here we go, ready? 3, 2, 1. Cap comes on, turn it upside down and count down with me. 5, 4, 3, 2, 1. Wow, we did it! And I got the catch. Very well done. All right. So, we see from that one experiment, right, that pressure can build up and we can move things. We can turn things into rockets. We can turn a film canister into a rocket with just a little bit of Alka-Seltzer releasing a gas, okay? But there's another experiment that I got here today, and it also has to do with pressure. It also has to do with, where's that? I got it. Mentos. Mentos, you may have heard of this one. Mentos and soda. Yeah, Diet Coke. Exact. And there's a couple of reasons we use Diet Coke and Mentos. Alright? And that's where the science is coming in, okay? So you guys may be familiar with this, but I'm going to do this experiment twice because I've done two different things to this, these two liters of Coke. One of them I've kept in the fridge all morning, so this one is really, really cold. And this one, as you guys can see from the bottom of it, is really, really hot. I've kept it in 180-degree water all morning, so that is ready to pop as it is, okay? Now, why do you guys think we use Mentos? Can anybody answer that? Why does this reaction require Mentos? You got an idea? That's what makes it blow up. You're right. You're right. It is what makes it blow up. That's why I'm going to use Mentos. But what's special about Mentos? Does anybody have any idea? What's special about it? You think sugar? Sugar is that's a very common answer. It's a good answer. Not quite though. So the surface of the Mentos have really tiny little dents, a lot like this ball. Okay? And those little tiny dents are what we call nucleation sites. You guys want to say that with me 3 times? Nucleation sites, nucleation sites, nucleation sites. All right, we said it 3 times, learning has occurred. So, nucleation sites are going to act as kind of a catalyst. You're going to hold on to those CO2 molecules inside the Coke and release them as a gas really fast. What else is special about Mentos? Are they going to sink? Does anybody know? Do the Mentos sink? Yeah, they do. They sink really quick. In fact, they're pretty heavy, okay, for candy. So they're going to sink all the way to the bottom. Why would that be important? We want to react with all of the Coke, right? We want a candy that's floating all the way down. We want to get to the bottom so that we react with all of the Coke all the way up, right? We're trying to make a volcano anyway, right? So, what about the Diet Coke? What's so special about the Diet Coke? It's diet, which means it does not have sugar. It does not have sugar. What does it have instead? Aspartame. That's right, I heard it. Somebody said aspartame. That's an artificial sweetener, and it's going to act as a little bit lighter thing, okay? It's going to make this reaction happen even faster than sugar would. And it's going to make my cleanup so much easier. Okay, so I think we've covered all the bases. We now need to make our hypothesis, okay, about which one is going to do a bigger explosion. All right? Now, think about the molecules inside the cold Coke. What are they doing inside? When you're cold, what are you doing? You're shivering, right? You don't move much, right? You huddle up, you come together, you go like this. Come on, guys, it's cold, right? Because it's really cold. By the way, on a hot, not July 4th day like this, a regular July 4th day, what are you normally doing? You're like, get away from me, it's too hot, you take your shirt off, your swim trunks, you go jump in the pool to cool down, right? So the molecules inside the really hot Coke, they're ready to bust out, right? They're excited, they're moving all around right now. And the one inside the cold Coke, they're frozen, right? They're like, oh my gosh, it's so cold, I don't want this. So, what do we think? Which one's going to be bigger? Alright, those of you that think it's going to be the cold Coke, raise your hand. Alright, just a few, okay. Those of you that think it's going to be the hot Coke, raise your hand. Oh, okay. Well, we're not unanimous, but I think we have a majority. Okay, so, first things first, let's do this, all right? I got my safety goggles on, I got my lab coat, I got the same amount of Mentos, okay, for each explosion. The only thing we're changing here is the temperature of the coat. All right. So there goes the lid. You can hear all those CO2 molecules inside the coat. Ready to go, right? Ready to go fizz. Okay. My canister is on. I'm ready if you guys are. Give me a countdown from 5, 4, 3, 2, 1. Yeah! Wow, right there, guys. I think that's as high as we got on the Diet Coke. That's a cold one, though, right? So the cold one got to about shoulder level. That's not bad. But I think I promised an explosion, right? Yeah, I promised an explosion. So I better give one, right? So, here comes the hot Coke, all right? Twisting the cap off very carefully. Whoa, did you guys hear that? Yeah, we're way more primed and ready for this one here, I think. Okay, same amount of Mentos, same Diet Coke, it's just way hotter, okay? All right, are we ready? Let me see if I can get it kind of straight up. Okay, give me a countdown from 5, 4,